Yeah.
I started.
So, Sajivan sir, shall we start?
Unmute.
Sajivan sir, you're on mute.
Yeah. Maybe you can wait for a few seconds.
Sure.
Because maybe many people are joining.
Still join. Yes.
Yes. Then you can look into the situation and you can take a decision and you can start. It is up to you.
Okay. Thank you.
You take the decision. Yes.
Okay, Sajivan sir, I think we should start.
Yeah, please go ahead.
Respected distinguished guests, members of Indian Society of Remote Sensing, my fellow remote sensing enthusiasts and students, welcome to National Remote Sensing Day celebration organized by Indian Society of Remote Sensing Pune Chapter. Every year, the 12th of August is celebrated as National Remote Sensing Day in India to celebrate on his birthday the legacy of great visionary Dr. Vikram Sarabhai, who is popularly known as father of Indian space program and consequently the father of Indian remote sensing. Keeping with this theme, today we have a talk by eminent scientist Padma Shri Pramod P.Kale on the topic of space, our future. I would now request Shri Sajivan Ji, Chairman ISRS Pune Chapter, to deliver his welcome address. Over to you, sir.
Thank you, Professor Navendu. Good afternoon and warm welcome to everyone. Today, we are here to celebrate National Remote Sensing Day on the occasion of birth anniversary of Dr. Vikram Sarabhai. You may be aware that ISRS Pune was inactive for many years. Today, along with the celebration, we are here to communicate to the geospatial community that we are back and we mark our status from dormant to active society. We can't but acknowledge the enthusiasm and community to revive the ISRS. After the ISRS election, The committee has done a lot more to be done. I am touched by the voluntary support from the community, especially the senior members. With all your support, we assure you that we will live up to your high expectations. Let me take this opportunity to request all ISRS members to go to ISRS homepage and update your contact details. And that is necessary to keep you updated on the developments of the society. On this platform, along with many senior members of the society, we are honored to have with us eminent honorable fellows of the society, Professor V.V. Peshwa and Professor P.Kale. Thank you, Professor Pramod Kale, for accepting our invitation to inaugurate the lecture series. Before I conclude, let me inform you all that in association with other societies, we will soon be coming up with a lecture series. We are fortunate to have a lot many eminent personalities, so a lot many success stories to unfold. Over to you, Dr. Navendu. Please take it ahead.
Thank you very much, sir. So today I have the honor of welcoming Shri Pramod Kale ji. Sir has extensive body of work, all of which cannot be covered within the time we have. So ask for his forgiveness for any omissions. Sir had worked with Indian Space Research Organization for over 30 years, during which he held various leadership positions. He started his work on satellite tracking at Physical Research Laboratory, Ahmedabad in 1960s. And he was a member of first team sent to Goddard Space Flight Center, NASA, USA, for training in launching sounding rockets in 1963. He also established the Tumba Equatorial Rocket Launching Station. He had worked as a research student with Dr. Vikram Sarabhai himself at Ahmedabad for over 3 years. Sir, in addition, was heading the Electronics Division, Satellite Systems, Space Science and Technology Center at Thiruvananthapuram. He was also project manager at Satellite Instructional Television Experiment, SAC Ahmedabad. He was project director at INSAT-1 Space Segment Project in Bangalore. He was mission director of ISRO Payload Scientist Mission, director of Space Application Center Ahmedabad, and director of Vikram Sarabhai Space Center in Thiruvananthapuram. Sir has received many awards and accolades. Most notable is Padma Shri, which he received in 1984. He is now devotes his time as an educationist, promoting science education for children from various strata of society, and also spends time with social work and community service. I now request Pramod ji to enlighten us with his vision for our future. Over to you, sir.
Thank you. Let me start by sharing the screen. Good morning to all of you. Let me introduce the subject. Is space going to be our future, or how we utilize the space is going to actually determine our future as to how and what activities we actually can carry out in space? We should be concerned about future, not just our own future, but also the future of mankind. When we think about the future, we should not forget the past also. Charles Kettering had said, "My interest is in the future because I'm going to spend the rest of my life there." In his famous book, Operating Manual for Spaceship Earth, Buckminster Fuller had said that we are all astronauts. We are in space, in orbit around the sun. Just think about it, that we are going around the sun at a speed of about 30 kilometers per second. We don't feel it. But then very interesting saying that I recently saw was, living on this earth is very expensive, but it includes an annual free trip around the sun. And that's what we're all enjoying in our life whenever we go around the sun every year. In 2003, at a lecture in Ayuka, our former president APJ Abdul Kalam was asked by a student, "What is your age?" President Kalam had answered that he was in his 73rd orbit around the sun. In the same spirit, I have now embarked on my 81st orbit around the sun. Today, 12th August, is 102nd birth anniversary of Dr. Vikram Sarabhai, who had started the Indian space program and inspired all of us. He had laid down the goals for our program. It was my fortune that I was able to work with him. The EOS 03 was attempted on 12th August, today that is, but the mission was unsuccessful. I wanted to share a few things about this particular satellite, the payload, and how we were planning to actually utilize that. This was our first attempt for having a satellite in the geostationary orbit, which would be imaging the Earth in multispectral fashion. And it would have given us large amount of information which is necessary, particularly when we are looking at what is happening to our forests, what is happening to the landslides, what is happening to the land itself. The satellite itself, with its payload, was quite an ambitious satellite. It has taken a long time, but then we would have been able to actually look at any given 500 kilometer by 500 kilometer area and achieved a resolution of 42 meters there. I think this was something which was really fantastic concept for which the Space Application Center was working for quite a large amount of time. It's unfortunate, but I'm quite certain that we will find out exactly what happened, why it looks like that there was a problem with the third stage, that was the cryogenic stage. What exactly happened, ISRO will really come back on that particular point and announce as to what were the problems and how best we are actually going to go ahead and solve these problems and move forward. "63 years ago, first satellites made by human beings were launched successfully in the orbit of the Earth. The first satellite was the Sputnik 1, launched by USSR on October 4th, 1957. And the second satellite was the Explorer 1, launched by USA on 31st January, 1958. I was a student in Pune at that time, and since then I have been studying space science, technology, and its applications in our day-to-day life as a subject. George Santayana had said that those who cannot remember the past are condemned to repeat it. We should try to understand the history, because from the history itself we learn as to what we tried to do, were we successful, and if we were not successful, why we were not, and how to correct for it in the future. It was really fortunate for me that as a student, whatever I was studying, immediately in 1960 itself, I started the work on the satellite tracking at the Physical Research Laboratory. And that was the one that really laid the foundation for all of the work which I carried out later on. These were those first two satellites, the Sputnik 1 and the Explorer 1. If you were to look at these particular satellites, you will suddenly realize that there were no solar panels. So the electrical power that was necessary for getting the radio signals back to Earth was only coming from the batteries. And once the batteries died out, the satellites also were not useful afterwards. In 1963, we started our first training work at the Goddard Space Flight Center for the rocket payloads. because we were going to establish the Thumba Equatorial Rocket Launching Station very close to Tiruvananthapuram. The whole concept was that we should be doing these rocket experiments near the geomagnetic equator, and the geomagnetic equator passes about 70 to 85 kilometers north of Tiruvananthapuram. This was our first launch, which took place on 21st November 1963. Since then, we had been working on various projects. One of the things that actually happened was in 1963 and SYNCOM was launched, and SYNCOM became the first geosynchronous satellite. And this was one of the satellites that was actually used to relay the Olympic Games, which happened in 1964 in Tokyo. For the first time, live Olympic pictures across the ocean were possible to be seen in the USA. This time, we saw the live pictures coming from Tokyo. Almost everybody in India was able to receive those particular pictures on their television screens, on their mobile phones. But the beginning had actually happened at that particular time. And as soon as the Intelsat as a consortium for the satellite communications was formed, India was very early in that particular recognition, and India became the member of the Intelsat, I think 1964-65 itself. And then we utilized the Intelsat 3 satellite for our communications, for the international communications, and that started becoming operational by 1971-72. This is the picture of the American satellite, Applications Technology Satellite F. Just by looking at the picture, you may not be able to get the size or get the correct idea of the size of it. But the antenna reflector that you see there is 30 feet or 9 meters, 9.3 meters or so in diameter. With such a large antenna on the satellite and a high power transmitter operating in the ultra high frequencies, it was possible then to receive the signals on the ground using a small receiving antenna. And this was our first experiment which we had carried out in satellite communications of this particular magnitude, that to be able to reach to any village in India, we should have that particular capability. And that experiment was very successfully carried out in the 1975-1976 timeframe, once this satellite became operational. As you can see here, that a small 10-feet diameter or 3.3 meter diameter antenna was developed at the Space Applications Center, and such 2,400 antennas and the TV sets were deployed in villages. So in some of the villages, they got the television signals first compared to many of the cities in India. This was followed up with our Aryabhatta satellite, the first satellite that was made in India, launched by USSR using the Intercosmos vehicle. And it had the scientific experiments, but this was the beginning of our making the satellites. This was the Rohini RS-1 satellite, which was supposed to be launched on our SLV-3 launch vehicle that was getting ready. You can see here Kalam, the project director, Professor Satish Dhawan, Shri N. Srinivasan, as well as Colonel Pant. And this is how on the SLV-3 it was launched. The last stage of the SLV-3, the fourth stage itself, was used as the apogee boost motor for our next communication satellite, and that was the Apple, or the Ariane passenger payload experiment. This was the first communication satellite that was built by ISRO and launched. It became quite a successful satellite. It had some problems with the solar array, but then it worked very well for the life for which it was really designed. We followed up with our INSAT-1 series, and in the INSAT-1 series, the first satellite became a problematic satellite, but the second satellite, INSAT-1B, lived way beyond its expected life. InSat 1B was launched using the space shuttle. As you can see here, the satellite leaving the space shuttle. On the NASA space shuttle, there was an opportunity that was available, and that is with our next satellite, InSat 1C, one of our Indian payload scientists could have gone up for doing the work of releasing the satellite as well as carrying on some of the experiments in space. Unfortunately, after the Challenger accident, which happened in 1986, NASA decided not to have any payload scientists coming from other countries on a commercial flight. So all the commercial flights were stopped at that particular time. That's our Indian remote sensing satellite, IRS-1. In 1994, 1993, our first launch of the PSLV was not successful, but the second one, the D2 flight, it became quite successful in 1994. And after that, PSLV has got a very good record of more than 50 launches. Today, we are dependent upon our PSLV, the GSLV, the type of the rocket that was used in today's flight. But carried out very good experiments using the same PSLV. We were able to put the Chandrayaan into the orbit of the moon. On the Chandrayaan itself, we had a moon impacting payload also, so that it could actually go and impact the moon. It was not a landing, but it was an impacting payload. Both the impacting payload as well as Chandrayaan orbit, whatever we had, gave us excellent results. And for the first time, we were able to confirm for the international community as well as for us also that there is water available on moon. Because this is one very important resource, which is if it is available somewhere in space, we should be able to use it for human consumption, as well as once water is available with our chemical knowledge, it should be possible for us to convert it also as a fuel. So if we were to establish a habitat on the moon, then from there, using that kind of a fuel, we could actually then go still further and beyond. Our next major thing was the Mars orbiter, and this became a very successful. It gave us excellent information regarding the Mars. Then we have launched the radar imaging satellite, RIASat, the hyperspectral imaging mission also. Today's launch would have given us a much larger amount of information in the hyperspectral region also. But it happens that, yes, something was not correct. Today, we are quite familiar with the navigational system that is available, the global positioning system of USA. There were certain administrative issues also, such that certain higher accuracy data was not available. Europe had then decided to go ahead with their own Galileo system. USSR had decided to go ahead with their Kronos system. Chinese have their own system. In the same way now, India, we went ahead with our own 7 satellite series, the IRNSS Navik. With that particular receiver that becoming available, it should then become possible for our defense people as well as for our fishermen as well as anybody else to get the information regarding their own position and utilize it for their own practical purposes. After the GSLV was developed, the next step was to develop the GSLV Mark III, which is one of the largest of the launch vehicles available today. We have used it for launching some of our very heavy communication satellites, and also it was used for the launch of the Chandrayaan-2. Chandrayaan-2 was not successful in terms of soft landing on the moon, but I think in the future we should be able to do it in a proper fashion. We have carried out experiments of the reusable launch vehicle as a technology demonstrator. This would be launched on a launch vehicle or a rocket, but then it can come back for landing in the future on the land. This is a very interesting satellite. It was made by the College of Engineering in Pune students. Just 1 kilogram in its weight, and this was one of the first successful satellites made by the students, which has functioned very well in its life. And I must say that they developed excellent management system also, apart from the technical system. For a very long time, we were getting good amount of information from the Hubble telescope. That Hubble telescope, its life was extended, it was getting to go out, but then certain additional information, which was not possible only on an optical satellite, was really necessary, and therefore AstroSat was conceived in India, and it is still functioning really very well in its orbit and providing us large amount of data. There has been some talk regarding the anti-satellite weapons, and these anti-satellite weapons have resulted in quite a large amount of debris also in space. In India, we have done one experiment, and that is about our mission Shakti, and it has shown us we have the capability. How to utilize it in the future will be determined by the government when the time comes for it. GSLV Mark III is also going to be our main vehicle for launching Gagan Yatris, or the astronauts from India. We have carried out the space recovery experiment. There is a satellite was launched and then it was recovered, and experiments were carried out as to what kind of things can be carried out in the zero-G environment. Our Gaganyaan systems will have a crew module which has got place for 3 people to sit and carry out the work. In the initial period, we will go through suborbital flight, but then in the later on, there will be a proper flight going around the Earth. The crew module will be launched using the GSLV Mark III satellite and its own escape system for the being able to actually rescue in case of a problem or astronauts has also been tried out. This was a crew module that was launched in the suborbital flight, which was then recovered. And that's the crew escape system that has been tried out, so that we are quite clear as to, in case of a problem, we should be in a position to go ahead and get the things going on properly. Apart from the human program, our next step is going to be Aditya. Here is a satellite which is going to look at continuously at the sun and get us the information regarding whatever is happening on the sun. And for this, the satellite is going to be located at the L1 point, or the Lagrangian point 1, between the Earth and the sun. And so it should be possible to continuously view the sun. Why are we doing all these things? When we are looking at various things, there must be some specific reason as to why we are doing it. The applications which were initially thought out were the space communications, meteorological Earth observations for natural resources, navigation, and geodesy. Now, very large applications of the space technologies, new ones have been developed, particularly when we are thinking about as to what we can do in space itself, not just only on the Earth. That's our satellite instructional television experiment, which brought the television to the villages. Earlier, it was very difficult for people to get the television signals. Today, you can see that, yes, television signals can be taken anywhere within the country. That also brought out large amount of work going on in the IT sector, and people started learning about it, even from the villages. Now the BPOs are being established there. After the satellite instructional television experiment, when the INSAT satellite was launched, one of the ideas there was that we should be able to establish a educational network. And this educational network was established. It worked for a certain amount of time during the INSAT 2 series period. But then a specific satellite, EduSat, was made and launched by ISRO. It was used for its lifetime, not fully utilized, but it definitely gave us the right kind of idea as to what is happening. One of the problems of using the satellite television for education has been that it was not interactive enough. In order to get the interaction going on, we needed to have some kind of a talkback capability, and that was then established using the telephones also. I'm quite certain that in the future, we will have education reaching to every nook and corner of the country. When the problems occurred in 1987-88 time period regarding finding the drinking water in the villages, one of the tasks that was taken up by the Space Application Center was to really look for the water wherever we can actually find out the groundwater. Now, the satellites images can tell us where is the water, not by looking at only the water, but also looking at the surface features. And that was the part that was taken up by Space Application Center and the National Remote Sensing Agency in those days for the National Drinking Water Mission. And the work carried out at that time resulted in our indicating the locations where water can become available with an accuracy which was earlier only 50% to 60%, right up to 96% or so. And today, that data is continuously being utilized and updated. One additional thing that happened with the satellite communications, particularly the two-way communications, was to use it for telemedicine. And this has become a very, very successful project today. All the communications were not just only for the land-based system, but they were also for the maritime, land, as well as aeromobile also. Communications were required for our defense people. Same is the case with the Navy and wherever they can go. With our satellites, it is definitely possible for us to look at whatever is happening on the Earth. This is a picture of the fire that took place near Mumbai, near Devnar. One of the very interesting thing that was actually seen was that if we were able to actually look at the sea surface temperature and then find out certain areas which are enclosed, hot water enclosed in the cold water or cold water enclosed in hot water. Anyway, wherever there is a temperature difference, we could then find out as to where the fish would go there for getting their food. And if we could tell it to our fishermen, then it would become easy for the fishermen to go there. And this was initially taken up as an experiment by the Space Application Center. And today it has now become a completely automatic operational system across our coastal areas. We get excellent quality images from our Cartosat series, the RadarSat series. On the INSAT INSAT 2 series also, and INSAT 3, we had the very high resolution radiometer type of a payload for meteorological imaging. The meteorological imaging from geosynchronous altitude gives us the advantage of being able to see the entire globe and at the same time look at a specific sector also both in visible as well as in the infrared region. That infrared region gives us additional information regarding the temperature of the cloud top, which then tells us at what height the clouds are. If we were to take multiple images and put them together, we should be able to then see how the clouds are moving, and from that we actually determine what is the direction in which they are moving and with what speed they are moving. Today, our imaging system, which has been functional since 1983, has been continuously providing us with this kind of a data, which we utilize for all of our meteorological predictions. And the satellite meteorological data has provided us as the major input. Considering this, a specific satellite only devoted for the meteorology was launched, and this was then given a name Kalpana in memory of Kalpana Chawla. These are the satellites that we have, which are providing us continuously the information regarding the cyclones, regarding the monsoon, what is happening, and how best we can actually go ahead and utilize our own resources for this kind of a system which is required. As you can see here, this is the image taken today morning, and then we can actually put them together to give us the animation. The first one was in the visible, second one is in the infrared region. Just look at the capability that we have today. That today in the morning, these images were taken, they were made into this particular system. I was able to download it from the meteorological department at 11 o'clock and talk with you today at 12:30 itself. A very remarkable thing that happened was that Planet Labs, a small laboratory, was able to conceive a satellite which weighed just about 3.5 kilograms or so. 104 satellites of this particular nature. On one of our PSLV mission, we were able to launch. After that, I went and saw the facility at the Planet Lab, and I was surprised that in a small facility, they were able to make such satellites. And they were able to make 5 satellites in a week, because if you have to have such a large number, the entire concept with which they started working was to build a satellite around a small commercial type of a telescope, the Questar, and build it up to make it into a satellite. Today, these Planet Lab satellites are providing us excellent data. So even from a small satellite of that nature, it is possible for us to get this detailed image. With the space-related things happening everywhere, one of the interesting things that came up was what exactly the astronauts would be eating in space. How do they keep their nutrition? So the food itself had to be developed such that it is zero bacteria, and at the same time, the food has got the natural taste, nothing artificial about it. And with just only addition of water, it could be reconstituted or it could be utilized as it is with certain amount of heating. The space food, the way it was developed, it was such that it had got a large amount of shelf life, does not require the refrigeration. That particular food, if you were to look at it, is something which has revolutionized even our entire food processing industry today. Same thing happened when Rakesh Sharma was to go for his flight in 1984. Around 1982 itself, the work had started, 82, 83, the work had started at the Defense Food Research Laboratory in Mysore to develop the type of food that would be necessary. The development of that food is one aspect, and second aspect is, can we grow vegetables in space? And yes, on the International Space Station, they have been able to grow. In the future, when we are looking at the habitats out in the space on a different planet, on a different locations, then yes, we will have to grow the food. But also the food growing has got one added advantage, and that is it removes the carbon dioxide and provides us with a oxygen output. The food that was prepared at the Defense Food Research Laboratory, not just only for the astronauts, but also the same food can be also distributed as relief material during the natural disasters. And it has really been extremely helpful for all the places where such food is immediately possible to be delivered. We always think about as to where is the space starting. So von Karman had defined it as to where the aeronautics ends and astronautics begin. That means there is no aeronautical lift, aerodynamic lift available at that particular density of the air. And there is a general agreement that 100 kilometers height above the surface of the Earth can be accepted as that. Since the advent of the space age in 1957, general public has been very much interested in all the activities concerning space. When we talk about space, tells us about adventure, tells us about mystery, tells us about the danger, tells us about the national pride, whichever way you look at it. Initially, space technology and space applications were thought through regarding the betterment of our day-to-day life. But now people are talking about space travel, space tourism, living in space, and space habitat in the future. Ideas regarding space travel and space tourism have been there in the science fiction even before the rockets and the satellites were launched. This is one of the latest things that has really fascinated a large number of people. This is a flight of a small helicopter on the surface of Mars. Mars has got very thin atmosphere, but even in that thin atmosphere, they were able to carry out this experiment because this would pave the way for the future transportation on the planet once you have landed there. And this is a very good experiment that has been carried out. And I'm quite certain that in the future, we will see many more such experiments coming up on Mars. Or if it were on the moon, they would have to use some different propellant, not necessarily helicopter. The Japanese Hayabusa spacecraft. This was a very interesting concept which was developed, and that is, it would go all the way up to an asteroid, and from that asteroid, it will touch down there, collect some material, and bring it back to the Earth. Pioneer has actually left our solar system and has gone beyond. I talked about the von Karman line. That is because Richard Branson was looking at development in a different direction, and that is something which can take off as a plane and can come back to land as a plane, but at the same time go and touch the space. As you can see here, a small plane is actually carried between two large planes which are there. It goes up to a specified height, and then the smaller plane separates and takes off and reaches to the space. Jeff Bezos from Amazon, he had been also looking at this kind of a thing, and that is his concept is that of the Blue Origin, a launch vehicle. This flight has taken place recently, and these 4 people went up there. Branson's Virgin Galactic went up also. As you can see, it has separated from the 2 planes and taking off and going beyond. It went up there, came back, and these are the 6 people who were there. There is one girl from India also, or Indian origin. I think this is the direction to go, actually, from the space point of view. As to there is adventure, there is something new that is happening, but this also opens up large amount of other opportunities in terms of space tourism, living in space, using the space for commercial purposes. The International Space Station, which was supposed to be completing its work in 1922-23, is now going to be extended to almost to 2027 or so. and it will be utilized commercially for processing certain things. For example, if a glass is processed as a material in space, we can get the purity to the extent as well as in the zero gravity. Then we can actually get the optical fibers which are going to be extremely good with lowest amount of attenuation, such that we can get longer range optical fibers in the future. There are certain alloys which are being thought about. There are certain pharmaceutical molecules which are being talked about, that if they are developed in space under zero G condition, there are many new things which are going to happen. I'm certain that whatever we had been doing for last so many years will continue to do more and more, and actually look at our bright future. But to ensure that we have a good bright future, we must understand as to what is happening on the earth in terms of what are the activities which we are carrying out, and how all these activities are actually going to affect us. Some of these activities are definitely affecting us, particularly it is now seen by everybody that our activities which are resulting in release of large amount of carbon dioxide and methane in the atmosphere is resulting in a major climate change. It's not just only we're talking about global warming kind of a situation, but basically we're looking at a total global climate change that is taking place, which is going to result in larger and larger, very high intensity kind of events which will occur. Sudden downpour, sudden loss of water, all those things are going to come up. The space activities, whatever we are carrying out, will also give us large amount of information. But also for the space activities in the future, we will have to look at as to how we can develop the fuels, the propellants, which will also not pollute our own atmosphere. Every time when we launch a rocket, yes, we do release a certain amount of pollutants in the atmosphere, but in the future, with our work that is going on, it should be possible for us to realize that we will have space vehicles which will not be polluting. Let me conclude by saying that if you reach for the stars, you might not actually get one, but you will not come up with a fistful of mud. You will certainly come up with stardust. Thank you very much.
Thank you very much, sir, for your vision. I'm sure all of us are inspired by the various milestones of space research our country has achieved. I now request Ms. Ashima Mishra, Associate Director, CDAC, to deliver the vote of thanks. Over to you, ma'am.
Please unmute.
Yes. Yeah. Hello, can you hear me?
Yes,
Yeah,
we
ma'am.
can.
Yeah. A lovely and warm good afternoon to everyone. I hope all are healthy and staying safe. The process of showing gratitude helps people feel more positive, relish good experiences, and build strong relationships. It's really an honor to offer the vote of thanks in the online event organized by Indian Society of Remote Sensing Pune Chapter to celebrate the Remote Sensing Day. On the behalf of the entire executive committee of ISRS Pune Chapter, I would take the opportunity to thank Padma Shri Pramod Kaleji for accepting our invitation and delivering an inspiring and thought-provoking lecture on this noble occasion. The committee is really grateful to receive constant guidance and support from all the senior members. On the behalf of the entire executive committee, I will take the opportunity to thank all the senior members. There is a lot of hard work has gone in the background to organize the online event. Let it be the ideation, design of the brochure, scheduling the event, reaching out to the remote sensing community, etc. The committee has put lot of effort in the background. I would like to thank all the committee members who actively participated to make the event a great success. The event would not have been complete without the remote sensing enthusiasts. On the behalf of the executive committee, I will take the opportunity to thank all the participants who have taken out time from their busy schedule and graced the occasion. Thank you one and all. Stay safe. So now I will hand over the session to Professor Navendu.
Unmute yourself.
Please unmute.
Thank you very much, ma'am. So I thank everyone once again for this wonderful occasion and gracing us with their presence. Thank you very much. I bid you a good day. Stay healthy. Thank you very much.
Thank you.
Thank you.
Thank
Thank you all.
you.